From emails to text to buying that thing you absolutely had to have from Amazon, we exchange data all the time over the internet. Hi, my name is Claire Wallace, and today I'm going to be talking about how our data is protected over the internet. A lot of times, the data that we exchange on the internet is personal. It's our names and birth dates and passwords and banking information. In the internet-driven world we live in today, data is being exchanged more and more. So it's important to learn what encryption means both in the past and present, how it works when data is exchanged over the internet, and what actions we can take to protect our personal data. First, we'll start with a bit about what encryption is and learn about its history. So a simple example of encryption can be found in celebrity ciphers from newspapers. They take quotes from famous people, assign each letter in the alphabet to a different letter, and rewrite the quote using the new alphabet. That's what encryption is, taking readable text, like celebrity quotes, using some sort of algorithm to mix the text up, like assigning each letter in the alphabet to a different letter, and finally decrypting the message, which would be solving the cipher. In order for it to be unscrambled, whoever is reading it must have the proper key, according to an article by Alison Grace Johansson on Norton. Now that we know what encryption is, let's take a look at the history of cryptography. According to Pandya's Brief History of Encryption, the concept of encryption has been around for centuries. One of the first known examples of encryption was the Skittily cipher. It was used by the Greeks and Spartans to send military messages. They would wrap paper around a cylinder, like the one shown, and write their message. The message could be decrypted if you had a rod of the same diameter. Another cipher is the Caesar cipher, named after Julius Caesar. As explained in an article by Tutorials Point, this simple encryption method is more widely known as the shift cipher because the message can be encoded by shifting the alphabet by a certain number and decoded by shifting it back. So for example, if the number was 3, A would equal D, B would equal E, and so on. The celebrity cipher is an example of a substitution cipher because one letter is substituted for another. Now we fast forward to World War II, and we have the Enigma machine, which was created by the Germans. It was notoriously difficult to crack. When it finally was cracked by the Polish and the British, it changed the outcome of the war, according to Pandya. Today, we have much more complex algorithms to encrypt data on a computer and over the internet. One of the more widely used techniques is the Advanced Encryption Standard, or AES. It is the standard encryption system that's used by all US government computers, and it is incredibly secure. Next, we'll move on to how data is encrypted over the internet. To begin with, we'll need to talk about the two types of encryption, symmetric and asymmetric. So I want you to imagine that you're passing notes to a friend in class, like they did in the olden days. And if your message has to go through a few classmates before it gets to your friend, any one of the people in between could read your message. This is a problem because what you have to say is for your friend's eyes only. So you decide to encrypt your message. That way, no one can read it unless they have the key, which you give to your friend during lunch. This is symmetric encryption. It's encrypting and decrypting data using one shared key. Advanced Encryption Standard is an example of symmetric encryption that's used today, and this type of encryption is used when you enter your credit card information online. One really big problem with symmetric encryption, though, is that the key must be shared between computers on a private network, and that's not possible on the internet all the time because it's open and public. This is where asymmetric encryption comes in. According to an article on surveillance self-defense, asymmetric encryption, especially when we're talking about the internet, is also known as public key cryptography. Khan Academy explains this really well in their video on encryption. Imagine that you have a mailbox that uses two keys. One key lets you put mail in the box, so you copy this key to give to your friends so they can send you letters. This is known as the public key because you share with everyone who you want to receive letters from. The other key can take the mail out, and since the letters from your friends are private, you don't share this key with anyone else. This is known as the private key. Now imagine this physical mailbox is your email inbox. When your friend sends an email to you, it's encrypted or made unreadable using your public key, and the message can be decrypted using your own private key so you can read it. Finally, let's talk about some steps we can take to better protect our personal data. According to an article on LifeLock, one of the best ways to protect your data is to make long, unique passwords and set up multi-factor authentication. I know it's so hard to remember all those passwords, but the article also suggests using a secure password manager to keep track of them for you. An article by the Forbes Technology Council also suggests checking on your passwords every year through your password manager to make sure that they're still safe and you can delete the accounts that you no longer use. Another way to protect your personal data is to make sure that the websites you go to are safe and secure. In the article by Johansson, one way to know if the websites that you're on uses encryption is if the URL begins with HTTPS. That S means that the website uses SSL or secure sockets layer, which means that the data is encrypted in transit. You should make sure that S is present, especially when you're sending banking or tax information or other personal data. From wrapping slips of paper around rods to complex algorithms that haven't yet been broken, we've come a long way in regards to encryption. Public key cryptography helps protect our data on the internet, and these simple steps will further that protection. So the next time you send a text, create a new account, or buy that thing that you absolutely must have from Amazon, you can not only trust that the information is secure, but you know that it is. Thank you.